Assalamualaikum. Today, a group of 5 people, will present about the oscillator. Our group member are Muhammad Firdaus bin Wahid, Muhammad Firdaus bin Hussein, Muhammad Izzaz, me, Izzuddin Lutfi, and Muhammad Fakhrul Azam. Introduction. Oscillator is a circuit which produces a continuous, repeated, alternating waveform, oscillating signal, including square wave, triangle wave, pulse wave, and as well as sine wave without any input. It also converts unidirectional current flow from a DC source into an alternating current signal without require any externally applied output signal. Here are some advantages of the oscillators. It has a very high efficiency. An oscillator is a non-rotating device. Consequently, there is a little wear and tear, hence longer life. And oscillators can produce waves from 20 Hz to extremely high frequencies and to 100 MHz. Due to the absence of moving parts, the operation of an oscillator is quite silent. It has good frequency stability. And finally, the advantage of the oscillator are the frequency of oscillation can be easily changed when desired. The oscillator condition. The oscillator conditions are based on Burghausen criterion. Introduce the feedback factor or loop gain which represent the condition of oscillation. The gain is infinite. The net phase shift is around 0 degree or 360 degree. It means that the feedback should be positive. The amplifier gain must be bigger than the loss in the feedback gain. When a loop gain are more than 1, it will rapidly cause the output to saturate at both peaks of the waveform and produce unstable distortion. If the amplifier gain more than 100, the oscillator will reach limit both peaks of the waveform. At the right side, there is a block diagram and also the formula. If A beta are less than 1, the output signal will be there out, which is called a damped oscillation. And if A beta are more than 1, the output signal will build up. And if the A beta equals to 1, the output signal will steady, which called undamped oscillation or stable oscillator condition. There are two types of oscillators. The first one is linear oscillator, and the second one is non-linear oscillator. For the linear oscillator, there is a feedback oscillator and also a negative resistance oscillator. In feedback oscillator, there are three types, which is LC oscillator, RC oscillator, and also a crystal oscillator. For the LC oscillator, the circuit consists of an inductive coil, L, and capacitor, C. In LC oscillator, the inductor and capacitor are connected in a parallel for a tank circuit. Tuned circuit can store electrical energy oscillating at its resonant frequency. Use radio frequency circuits because of their ease of implementation and good phase noise characteristics. Here, we included three examples of LC oscillator. The first one is Hartley oscillator, second, Colpitts oscillator, and the third one is collapse oscillator.
Assalamualaikum. My name is Muhammad Fakhrul Azam bin Salehan and I will continue to present the slide. The second type for the feedback oscillator is RC oscillator. RC oscillator consists of resistor and capacitor. RC oscillator uses a combination of an amplifier and an RC feedback network to produce output oscillation due to the phase shift between the stages. Type of feedback oscillator consists of an amplifying device, resistor, vacuum tube, and op-amp. In order to achieve positive feedback, output energy is feedback to its input through a network of resistor and capacitor. RC filter type combination are preferred to generate sine wave at low frequency. RC oscillator are also known as the audio oscillator. The example of RC oscillator is Wean bridge oscillator and phase shift oscillator. The third type for the feedback oscillator are crystal oscillator. Crystal oscillator is an electronic oscillator circuit that uses the mechanical resonance of a vibrating crystal of piezoelectric material to create an electric signal with a precise frequency. The crystal oscillator circuit sustains oscillation by taking a voltage signal from the quartz resonator, amplifying it, and feeding it back to the resonator. Crystal oscillator is mainly used in the application where high frequency stability is important. The application of oscillator. First one, crystal oscillator in the quartz watch. Crystal oscillator can keep track of what time it is. Crystal oscillator can create a signal with a very precise frequency, so it is more accurate compared to the mechanical clock. And generally, some form of digital logic counts the cycle of this signal and provide a numeric time display, usually in unit of hours, minutes, and seconds. Second one, oscillator in the radio. AM radio transmitter uses an oscillator to create the carrier wave for the station. AM radio receiver uses a special form of oscillator called a resonator to tune in a station. The third one, oscillator is used in the smartphone. In a smartphone, the transmitter and receiver circuit contain the oscillator. It produces the radio frequency signal, which are then converted by the phone antenna into incoming and outgoing electromagnetic wave. In today's, the oscillator are silicon based and use the charge of an electron to create microwave. The fourth one is oscillator in the stun gun. Oscillator in the stun gun act as a component that fluctuates current to produce a specific pulse pattern of electricity. That's all from us. Thank you.